Hi guys, this lesson is about triangle midsegments specifically, but we're also going to talk about just the parts of a triangle that are proportional. And so let's start first of all with this triangle proportionality theorem. It says if a line is parallel to one side of a triangle and intersects the other two sides. So here's an image that we have here. And so if you notice, RS and XY are parallel and they intersect the other two sides of the triangle. So XY intersects RT and intersects ST, and RS intersects the same two sides. Okay? It says then it divides the sides into segments of proportional lengths. So essentially what we're saying is it divides these two segments. This segment XT is and TY. Those are the two that we're going to call the bottoms. And RX and SY are going to be blue. So we can write ratios of the blue part over the pink part and the blue part over the pink part. Okay? So that's what this is saying. The blue part over the pink part and the blue part over the pink part. Okay? The other thing that we need to know is that a midsegment of a triangle, that's a new vocabulary word, midsegment. And a midsegment is parallel to one side of the triangle. So like XY is parallel to RS, like we talked about in this triangle up here. And that we know that the length XY is going to be 1/2 of RS. Okay, so this length right here is going to be 1/2 of this length right here. Okay, so XY is our midsegment. That's a midsegment. And why do we call it a midsegment? Well, there's a couple of reasons. Number one, it's in the middle of the triangle, and it is a segment. So midsegment means it's in the middle, halfway in the middle, and it's a length. But then also, it means that this point X right here, that's the midpoint of this line RT, and this point Y right here is also a midpoint of TS. So a midpoint means that it cuts it in half, right? So this mid-segment right here has now made this segment congruent to that segment, and this segment congruent to that segment. Okay? So if they say something is a mid-segment, that gives you a lot of clues about your problem. So they say they've got this formula, XY is 1/2 of RS, or you can say that RS equals 2 of the XYs. Okay, so we could say that the long one is twice the small one. So there's two different ways to think about it. So if they're asking you to find the long one, you just multiply by 2, and if they're asking you to find the mid-segment, then you divide by 2. Divide the base by, or this segment by 2. Okay? All right. So that's just an explanation of some vocabulary. So let's go to the inside and answer a few questions. So looking right here, it says, in example, or in triangle ABC, EF is parallel to CB. They want you to find X. Okay? So looking at this, is EF a midsegment? So remember, a midsegment is parallel, and it's going to cut these two side lengths in half. So just looking at this, we can't tell what the X is, but we can tell on this side. Does this line EF, does it cut this side in half? No. So this is not a midsegment because of that. Even though they're parallel, this is not a midsegment. But I do know, based on this proportionality theorem, that if I have two parallel lines, then those parts are proportional, right? There's little proportional parts. So let's go ahead and mark that. So we can say AE and EAF would be blue, and then these parts right here on this side would be pink. And so remember, we want to do blue over pink or pink over blue, it doesn't matter, but the blues are on top and the pinks are on bottom of our fraction. So I made two fractions here. We want the blue lengths on top and the pink lengths on bottom. Okay? So 18 on top of this one, 6 on the bottom. 18 goes with 6. So you stay on the same side of your triangle when you write your fraction. Then x plus 22 goes with x plus 2. So notice I'm staying on the same side of my triangle. And now knowing how to solve those proportions from the last unit comes in handy. Remember we put parentheses around those? So we say 18 parentheses x plus 2 equals 6 parentheses x plus 22. And you go ahead and solve this problem. So go ahead and solve the problem, and we'll go ahead and show the answer in just a second. Okay, so if you were waiting for me to show you how to solve this problem, I obviously solved it before that. So if you don't know what's going on here or you need some help, please raise your hand, but make sure you pause the video and check your work if you did not get 8 for your answer for x. Alright, let's look at example 2. On example 2, we have two lines. They don't say they're parallel, but if we look over here, what do you notice? Is this length here, PQ, is this a mid-segment? Yes, this is a mid-segment because BP and PA are congruent. 8 is congruent to 8, and CQ and QA are also congruent. 9 is congruent to 9. So we know this is a mid-segment. So PQ is a mid-segment. So now we know that how does a mid-segment relate to the parallel side? Well, the mid-segment is going to be half of the parallel side. So if I do 6 divided by 2, I get 3. So x is equal to 3. Okay? That was pretty simple. Let's just half. Hold on. Okay, example 3. Sorry, I had a slight interruption, and that's okay. Example 3 says to find x. Now, unfortunately, I did not say that AB was a mid-segment, but we're going to say that it is here. So AB is a mid-segment. You can't just assume that, but I forgot to include that on my words, so that's missing from your instructions. So AB is a mid-segment. How would we find x? Well, I know that AB is half of xz. Does that make sense? Or I can say that 2 times AB is equal to xz. So to solve this problem, it's probably easier to multiply this by 2 and say it's equal to that 34. So I would say 2 times 3x minus 1 equals 34, and then solve that equation. Okay, so go ahead and solve that equation. Okay, and just like before, x is equal to 6. If you did not get the correct answer, please pause the video and check your work and see where you might have made a mistake. Okay, so let's look at the next problem. The next problem says, in triangle GHK, let me get up there. There you go, example 4. In triangle GHJ, HK is equal to 5, KG is equal to 10, and JL is 1/2 the length of LG. What is HJ parallel to KL? So we're trying to figure all of that out. I'm going to use a different color pen because it's kind of bleeding into this purple problem over here, but let's label it. So HK equals 5, KG equals 10, and JL is 1/2 the length of LG. So JL, that's this one, is 1/2. Let's call this X. So this one is 1/2 of X. So the question is HJ parallel to KL? So I don't know anything about the lengths of these, but I know it's not a mid-segment because 5 and 10 are not equal. In order for this to be KL to be a mid-segment, remember these have to be the same length. But this other formula said that if I can write proportions and they're congruent, then they're parallel, right? We can say the opposite, the converse of the statement. So let's go check here and see. So let's mark them with our colors. So 10 is blue and X would be blue. And then 5 is pink and X, 1/2 X would be pink as well. So remember, we're going to write blues on top, pinks on bottom, and we're going to stick to the same side of the fraction, right? Or of the triangle, right? So 10 over 5, because they're on the same sides. And then over here, X over 1/2 X. And lots of you get freaked out when we see fractions. It's okay. Alright, so let's cross multiply. So we get 5x equals 10 times 1/2 x. And go ahead and solve that and see if you get the same, that they're congruent there. Okay, so when I multiplied 10 by 1/2, I ended up getting 5x. And so 5x is equal to 5x. So then that means that these cross products are equal, so that means that's a proportion, okay? That's another way to check to see if a proportion is true. So we can say HJ is parallel to KL because of these fractions being proportions. Okay? All right, the last question here is example 5. And so in example 5, it says that XY, I'm going to make that one pink, and XZ, they call them midsegments. So remember what we said about midsegments, that they cut the side lengths in half. So let's just talk about the pink midsegment for right now. The pink segment is a midsegment, so that means RY and YT are going to be the same length. It also means that it's cutting this line in half. So XS and XR will be the same length. So because of that pink midsegment, it cut this line in half and it cut this line in half, because that's what midsegments do. XZ is also a midsegment, therefore this Z is the middle of TS. That's what midsegment means. Remember, it's the middle. So that means that these are also congruent. Okay, so that's all the things I know about a midsegment. So let's move on. It says, find the length of XZ. So how long is XZ? That's this length right here, the blue length. So let's start with that. So XZ is the midsegment, so that means it's parallel to another line, right? It's parallel to RT. So if RT is 13, then XZ is going to be half of that 13, right? So what is half of 13? 7.5. Alright, now we got to find ST. Look, notice how I checked off what I found. Now let's find ST. So ST is this length right here, and is there a midsegment that goes along with it? XY. Well, ST is the longer side, so it's going to be twice the pink line, so 2 times 7. So ST is 14. Okay. The last thing it asked us to find was the measure of angle RYX. So here's RYX. Okay, they want us to find the measure of that angle, RYX. Measure of angle RYX equals, so remember what we talked about, that the midsegment means that we're parallel. So we're going to have to use some of those ideas that we learned back when we learned about parallel lines. So I know that XZ is going to be parallel to RT. You all agree? So what kind of angles are these two angles right here? Remember, they're alternate interior because they alternate over the line and they're in between the two parallel lines. So if this angle is 124, then this angle is also 124. Okay? Alright, I've answered all the questions on that problem, so I am done. Thanks for watching. Have a good day.